Now we are going to learn about the next property of light called diffraction of light. Here I have summarized all the points related to diffraction of light. Already I have learnt about few properties of light: reflection, refraction, and then interference of light in the previous sessions, and that one was already taught in the class. Now this diffraction of light is also another important properties of light. This is also one of the properties of light. What is diffraction of light? The definition of diffraction of light may be asked in the examination. For that purpose, I have written the complete definition of the diffraction of light. So, what is diffraction? Bending of light around the edges of the obstacle is called diffraction. Here, you should know the meaning of obstacle. So, whenever light travels in the air medium, if any obstacle is placed, obstacle means that one must be a opaque substance, or it may be a small narrow hole. Here you can choose any one of them as obstacle: small narrow hole, or edges of the blades, or head of the pins. Among these three, any one of them can be taken. So if it is placed in the path of the light that one will bend around the edges of the obstacle. Because of bending, what happens? That one will form the diffraction fringes on the screen. That is central maxima. On either side of the central maxima, bright bands with lesser intensity bands will be created. Such kind of fringes can be observed in diffraction phenomena. Later in the next slide, I will explain how the diffraction occurs around the edges of the obstacle. With the help of ray diagram, I will explain. This diffraction property of light that can be explained by wave nature of the light, not with the help of particle nature. Wave nature that helps us to explain the diffraction of light. And the most important thing is, while choosing the obstacle, the size of the obstacle must be chosen in a such a way that it must be too small, it must be thin or too small compared to the wavelength of the light. That is very important. Among the three, any one of them can be used as obstacle. So these obstacles, they will cause the diffraction effect. And finally, on the screen, you can observe the diffraction fringes. As seen in the case of interference, here also diffraction fringes bands are created, and that can be seen on the screen. So this is a fundamental idea about diffraction of light. Okay. Now I am going to explain how the diffraction effect that could be observed with the help of this experimental setup. Here we have to place a source of light. Nowadays laser lamps are available. So this one may be a laser source. Therefrom the monochromatic light that is made to incident on the obstacle. Here obstacle is nothing but it is a slit. In a small sheet you have to make a small hole, narrow hole, that may be of in rectangular shape. Very small, narrow, thin slit must be made on the paper. It's a hole. Okay. So from the source, the light is emitted. The laser lamp that emits a single colored light. So the light that comes from laser lamp that is made to incident on the which one? That slit, obstacle. But we know about the rectilinear propagation of light. Rectilinear propagation of light means the light travels in straight line. Such property was already taught even in the lower class. So as per the rectilinear propagation of light, the light it has to travel in the straight line, and here the shadow region will be created as per the property. Here the shadow region must be created. So this portion alone must be illuminated. So clear, when light passes through this, the light will pass through this region. I will draw this. Here the light will travel in this region, and that portion alone must be illuminated. Are you clear? So the rest of the portions must be shadow. Are you clear? Geometrically, these regions must be a shadow region. But it is not so. Clear? Due to the diffraction effect, when the light incident on the obstacle, the light rays, they start bend around the obstacle. Are you clear? When as soon as it hits on it is incident on the obstacle, around the edges, what happens? The light starts bending. After bending, what happens? It bends in this direction. Now I am going to draw the diffracted light. How to draw the diffracted light? Due to the wave nature of the light, it bends around the obstacle. So due to bending, it goes like this. Due to bending on either side, the diffracted light, it bends around the edges of the obstacle. Because of the bending nature, here this central bright band is created. No, on either side of the central bright band, you can observe few bright bands with lesser intensity. Are you clear? This one could be called as first maxima, second maxima, third maxima, fourth maxima. So like this, just below to this, first maxima will be created, second maxima will be created, third maxima will be created, fourth maxima will be created. But among all this maxima, the central maxima will be the brightest one. These two maxima will have same intensity. If you go to second maxima, compared to the first maxima, the intensity of the second maxima will be lesser than the first maxima. Are you clear? Like this, a diffraction pattern will be created due to the bending of light. Are you clear? We are going to learn thoroughly about how the mathematically how the fringes are created, what are the conditions to obtain the fringes, all those things to be taught in the next presentation. Here, on either side of the central maxima, dark regions are there. Are you clear? These are all the two dark bands are there. So here all you can observe the dark bands. So few fringes are observed. You can't observe many number of fringes as seen in the case of interference of light. In the case of diffraction of light, very lesser number of fringes will be created. Are you clear? So this bending nature of light around the edges of the obstacle, that one causes the diffraction fringes. Are you clear? So this must be clearly understood. Are you clear? So this is the diffracted light. I will draw the region. Are you clear? So this is the region in which that light bends around the obstacle. Are you clear? So be thorough with the concept. Again, is it clear? I will teach the same concept, is it clear, in diffraction in single slit. Okay. Now I will explain the same diffraction effect when it is seen in the case of circular aperture. Look at the obstacle. So here a sheet to be taken, there at the center one small narrow hole is made. The shape of the hole is almost circular in nature. When the circular aperture, when it is illuminated with the help of laser light or by using any other monochromatic light, after illumination what happens? As seen in the case of the previous one, here also around the edges of the obstacle, the light starts bending. Are you clear? As soon as it hits on the obstacle, instead of traveling in the straight line, the light bends around the edges of the obstacle, and because of bending, because of the diffraction effect, these kind of diffraction fringes are created. They are circular in nature. Are you clear? Look at the middle portion of the circular fringe. Actually, is it clear? This portion, this portion that is illuminated as a central circular region. Are you clear? So you can extend the line and you can see the portion here. Are you clear? This portion is illuminated, brightly illuminated. You can see the bright spot here, bright circular spot here. Around the bright circular spot, few fringes are formed, and almost all fringes, they will be circular in nature. Are you clear? One or two circular fringes, they are formed around the bright spot. Are you clear? Since the obstacle, it is in the form of aperture hole, the middle portion is illuminated, and around the bright spot, here dark ring is there, bright rings are there, around this concentric rings are formed. So these kind of diffraction circular fringes are seen whenever we use the circular aperture. Are you clear? So the depends on the shape, the nature of the shape of the fringes also, that will become different. Okay.